All right. Thanks this morning. Looks like we'll sort of kick off now. Most people are sort of coming on. We've still got a few stragglers, but typically with these sorts of webinars, people come on at all sorts of times. So we'll kick off. Just wanted to quickly give you a bit of a rundown on what we're going to do today. I've got a very short presentation just so at least you can see sort of what we're after, what we're up about. So today we're doing cost-effective troubleshooting focused at remote university education networks. The reason we're doing sort of university education networks is over the last couple of years, we've had a lot of discussions with a number of unis with sort of remote site monitoring and the challenges that remote site monitoring presents for them, especially with schools, universities, TAFE colleges, with lots of distributed sites and distributed faculties and offices and again schools and things like that. Centralized monitoring is always difficult to monitor out, not only to the edge, but like once you go inside that site. So the only way to really get that is you either have to have some probes on the inside of the network feeding back centrally, or someone's got to do some remote triage for you. And generally what happens is if something's seen centrally that there's a problem out of the site, it usually requires someone to get out there, start looking at packet captures, start trying to work out where things are going and what they need to do. So I guess what we're trying to do is give people an understanding of there are ways of troubleshooting these sorts of environments in a cost-effective manner without having to deploy engineers to go out with laptops and Wireshark and things like that. Wireshark's a great tool. Laptops are good for doing troubleshooting. But when you start to push towards 1 gig and 10 gig and you're trying to do line rate monitoring, you don't want to drop packets, Wireshark tends to struggle. I mean, a laptop NIC will do maybe 600-700 meg before it starts dropping packets. And Wireshark won't see that. I mean, you'll drop packets and you'll have no idea. So we're going to try and look at a couple of ways to do this easily and really without having to go and deep dive for packets. I mean, not everyone's packet junkie, so I'm the same. I try and stay away from packets as much as I can if you don't have to. So we'll get into it. So the agenda to today, we're sort of going to look at understanding spurious remote traffic patterns. So we're going to investigate users causing issues on the network. Now, in some of the examples you'll see, this is taken from actually a remote site, that remote site being a COVID stronghold, which is my home office. But there's 46 or 43 users or 43 devices on my network, pretty much split between wireless and wired. And there's lots of things going on, understand, especially with homeschooling and things like that at the moment. So, which has just passed. So you'll see that there are things that can cause problems. So what we want to do is we want to look at, just some interesting traffic patterns that we see, wondering what that is, and then trying to work backwards and work out where that comes from or what actually it is. The second one is, which is a really important, is understanding site latencies and their impact. So one of the key things that we've had with a number of clients over the years is, how do I know my latency out of the site coming in? Okay, from centrally monitoring, you can look at the latency maybe of an application coming in from a remote user. But what you can't see is what's going on actually in that remote site. If you want to look in front of a switch and on front of a router on the other side of a router, is the router or is a firewall or a load balancer on a remote site causing delay that's actually nothing to do with the client, nothing to do with the application, and maybe nothing to do with the network in the middle, be it a private network or being a carrier grade network. So we're going to look at both hops, or looking at multiple hops, and then sort of trying to work out how we can see whether it's application or network. And then we can also compare to other users, so determining, is it just for that user, is it just for that application, or is it actually across the board? Then the third one, we're just going to go into some TCP problems, trying to get into zero windows and have a look at retransmissions and just try and get into those things quickly. I mean, you can capture packets and packets of data and then do a quick zero window check on packet captures, but sometimes you want to see it contextually and see whether it matters. And generally, the first two of these areas, we're actually going to look at and we're not going to look at packets at all. The third one, we will actually go and have a look at the packets because that's, it's interesting to see. But the first ones, we don't really need to go and see packets. So, and then maybe if we got some time, just a couple of bits of weird DNS stuff that I saw just the other day, and you know how you can do it for DNS. So the topology that you see here is we've got a couple of APs going through a PoE switch, through a Cisco 3750, through to a gateway, then through to a router modem, which is actually in my home office, into the NVM black box, and then the internet, which is sort of represented in this single icon there. We're then going to tap. I'm actually tapping across the trunk from the 3750 to the gateway, and I'm also tapping from the modem out to the NVM cable modem. So what I want to see is I want to see what impact are my devices causing, and you know, is there any delay? Is there any problems? And this is all going back into an IOTA 1G. There's 2 ports on that. So I could have put this into, actually, this is actually going through, these tap points are going through an aggregator as well. So I've deliberately put them into two different ports. But if you had 2 ports going into an aggregator, you can put it into just into 1 port. But for the sake of the exercise, the example is fairly accurate. And then what we're actually going to be using today. So we're using an IOTA 1G from Profitap. It's got 1 terabyte of onboard storage. They've got integrated dashboards, which we're going to use extensively. That's what's going to give us the information. And because it is a very, very good remote device, it's got some very cool remote access. So you can either connect it to a network via management and remote in if you're on the same network, or there's actually an inbuilt 0-tier. It's like a secure tunnel that you can tunnel into this from a remote perspective and get in to have a look at data as well. So we're going to do that. There is a 10 gig version available. We're only using the 1 gig at the moment. And then we're going to do some packet analysis using Capsa from Colosoft. This is really a bit of like a Wireshark on steroids. It does a lot more than just giving packets. It actually gets in and gives you some TCP connectivity. It looks at problems. It looks at some diagnosis. So it gives you a bit of expert analysis. Both of these sort of fall under the line of cost effective, and we'll talk about that a little bit later. So I'm going to switch over now. So switch over to the IOTA dashboard. Now, IOTA, as you can see, it's just basically a web URL. I've actually just got this set up as my DNS server as IOTA 1G. But when I first jump on, this is the home dashboard. It's just looking at generally traffic coming in and coming out. As you'll see, I've got the last 3 hours of traffic. I've actually zoomed my screen in just so you can see some of the finer details. Usually I can see this all on one screen, so apologies for scrolling backwards and forwards, but you'll actually see where we're going for that here. Essentially, just to really look at it, there is a data vault, which is the guts of what IOTA is all about. And what this does is this grabs all my files and stores it in 30-second increments. And those 30-second increments is what happened, is how it stores data to the hard drive, and it then indexes all those files that present this data in a simple to use dashboard. So it means that you're not diving into the packets, you're actually going to the dashboard where all the packets are actually indexed and presented to you in a full view. So I could go back, you know, 6 hours, 12 hours, whatever the case might be, and all that's doing is that's taking 30-second chunks of packets that are actually stored on the data into a meaningful display of on the dashboard. So what we're going to do is there's a couple of those 3 examples. So we're going to start with Spurious Data. The other week, I was actually working late at night, and I had these regular spikes occurring on my dashboard just under here, where these spikes are here. And they were so pronounced because there was not much going on. I was sort of really confused what it was. So rather than going out and asking loads of people, I actually just sort of drilled in and thought what I was going to do. So in remote environments, these type of events sort of can impact users unknowingly. And of course, centralized monitoring can't always see what's going on behind the edge router or behind the switch or behind the firewall. So how do you explain to a user that's maybe seeing problems, but
they're not really got visibility into what's going on. So this is what I did to actually sort of discover what was going on with my traffic and whether it was actually important or not. So I will go back in time. As you can see, there are like lots of different times. You can go yesterday, day before yesterday, last 6 months, last 30 days. I'm actually going to use time ranges for this, mainly because I've actually got some data I saw. This example that I'm showing, I actually recreated it as well because it was actually interesting enough that I thought I'd do something around it. So I'm actually looking over just a half-hour period between 12 o'clock, 12:40 and 1:10 on the 26th. So as you can see, never mind this one, that was something else I was looking at. As you can see, we've got these regular spikes, and it was actually interesting to see. And this is probably not as pronounced as what it was before, but before they were like bang, 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 and like literally nothing. And I thought, well, what are we looking at? So you can see there's like 235 meg of data here, 146.1 meg. There's 480 meg all up. So the old Wireshark ways was I capture all that, I download that, and then I sift through it. Now, 480 meg, okay, it's not as much as what we saw before. When we were having a look at back 3 months, it's like, sorry, three hours, it was like 2 gig. So doing a 2 gig capture in Wireshark can be problematic. So the easy way is just go and have a look at one of those spikes. What's going on? So what I did is I drilled into this spike, right? So you can see we're now down to, from 480 meg, we're down to 9.4 meg. So instantly our triaging is a lot easier. And I can see that there's 2 IP addresses here. One's got 4.73, 1.465. Now, just to go back to our example, we were tapping in 2 spots. This is the external IP of my modem, and this is my internal IP. So we're actually seeing the same traffic twice. So this 9.423 meg is actually only half of that because we're actually capturing it twice. But it's really good for multi-hop to understand. You just got to be aware of that when you're doing, especially when you're doing multi-hop analysis, you got to understand you're seeing the same traffic multiple times. But the intelligence of IOTA is that when you download packet captures, it doesn't download the same packets. It actually won't show you a whole lot of duplicates, because if you went into Wireshark and tapped in these 2 spots, you'd see a SYN there, and then you'd see a SYN there, and then you'd see an ACK, a get, and so you'd actually see all this traffic replayed or duplicated. So what we're going to do is we're going to actually filter on that user, and then we'll see that the main server in this in the conversation is this one here. These ones are a bit of multicast. This one is the main thing. So we're actually going to filter in and have a look at what's going on. Now we're actually down to 4.65. So what we're going to do is I'm sort of bouncing around a couple of screens just to show you that what we can do now that we've got our filter set and now that we've got our time zone set, we can actually go around to different views, keeping the same context in terms of filters and time zones. I mean, if we swap screens, we don't lose all our filters, we don't lose all our time periods and things like that. So it makes troubleshooting really easy. So what we can do is we can actually go into application latency, and we can see that, sure enough, this client is looking at YouTube. Now, this client is actually my iPad. Yes, I was on YouTube and I was playing videos. The actual example was my son was actually watching a whole lot of YouTube videos, and it's just the way, obviously the way YouTube works. But I didn't know that, and so we were sort of trying to work out where the problem was. So what we've done is we've actually looked at average. Now, average latency, max latency for the application is good, but we instantly know that it's a YouTube app, so which is pretty easy. I mean, if it's a HTTP, if it's SSL, we'll put it up there. If it's IMAP, we'll see it as well. So what I'm going to do is I'm actually going to go over and have a look at our hosts. Again, we're keeping the same context. Now I can see that that's my iPad, that's my server IP. It's actually going back to my service provider, which is TPG, which happens to be which happens to be in Australia here. So it's actually hosting or serving that locally. So interesting to know, we're not going overseas at this moment or anywhere else. So what I can do is I can then go into the flow, and that flow is just going to look at, because we're still looking at just this, 5404 to 50, we're looking at 2 seconds worth of data.
So over 2 seconds, we've done 4 meg. So basically, 2 seconds, we've done bit over 4 meg. 1 second, we're probably doing a bit over 2 meg. So, so about 16 megabits a second for that sort of data. So what's the really cool thing here is the way IOTA indexes all the traffic is when it sees a flow, it actually puts a hash to it. So you can then say, right, what we're going to do is we're going to filter on that hash. So now we've got a source, a destination, and a flow hash. So that's just specific to that application and that particular flow. So what that means now is that we can then go back, maybe zoom our window back out to our custom time, which was originally 1240 to 1310. And you can see instantly now, and we can go back if we want. We can go back to the home dashboard if you just want to see the data there. So we've gone down now to what was 480 meg, down to 105 meg. So we can see that this is purely related to that application in YouTube. And this is the way that YouTube grabs data, 1253, 1253.30. So every 30 seconds, YouTube goes out, grabs a chunk, brings it down, stores it. Now, of course, with my network, I've got enough overhead to cater for that. But if this was a remote site, maybe behind not a NBN link, but behind a slower link, someone's out there or multiple people are out there using YouTube. I mean, that could impact other users significantly. So, we could, realistically go back into, dashboard, and we could filter out, say, the server and the flash. See, the beauty is, shows what the hash does. I've actually taken out the server, but because that hash is still linked to that server, it still keeps that context. So it shows you, regardless of what else is going on, I can zero down to that specific thing. And then if I then remove the filter, then I can see everything else that's going on. I can see that IP address at the same time as what's going on here, it's going off doing a whole lot of other things. Of course, I could sort of go into some other windows and sort of say, show me my performance, so you can see what's going on here. Or you could sort of just say, listen, show me some server latency and show me some other things that are going on. So obviously there's Netflix, there's Apple Store, there's Google, there's more YouTube. So, there's a lot of data there, and there's a lot of application latency, but just zooming into that specific thing sort of gets you out of the weeds, but gets you into the correct application that we're looking for, or the problem that we're initially trying to understand. So which leads me to, I'll go back, I'll clear out all my filters. So I could have cleared filters this way, that does the same thing. That all instantly takes me back to my time range. So I'm back to 1240 to 1310. This time I'm actually going to change my time. I actually want to go out a little bit further to 1340. I'll go back to my dashboard. Home dashboard is not a bad place to start. You get a pretty good understanding. So as you can see, I've got 1.76 gig worth of traffic. So, I had a complaint from a user. Let's just say a user was probably a younger person than what I was, about an Apple TV device. Now the Apple TV device is actually this IP here, but it was around this time frame. And so what I was going to do, rather than click on this and just drill in straight to the IP, they did say that it was around 1:30. It got really problematic. So what I'm going to do is I'm actually going to zoom into this bit anyway, and then I can zoom into that more, and then I can start to see, yep, 171 was obviously downloading a little bit of data at that sort of time. So what I'm going to do is I'm actually going to have a look what's going on, but I'm going to go over to my application latency and have a look at my 171 here. And what I can see here is that I'm now looking at that point in time from a couple of different perspectives. Yeah, I know what the IP address is. I know what the application was, and I sort of saw the spike of when it was, and I thought I'd check that out first. But what I want to do is I actually want to filter now just on that application. So I'm actually going to pick Apple TV. So now you'll see that I've got two addresses here that register for Apple TV, or the HTTP Apple, which is actually my Apple TV going through my gateway. But the example here I want to show is, and the reason I've done it that way, is because I want to have a look at both those IPs. If I filtered out just the 171, I would actually lose the visibility of what I'm seeing from the gateway perspective. I want to keep the gateway relevant to my troubleshooting. So what I've done is I've actually gone in and just said, give me the protocol name, give me Apple, see what goes on. So as you can see, even the application latency, average latency for the application is 23.89 milliseconds and 7.71 from the gateway perspective. So across 2 hops, I've got about 16 milliseconds, or 16.18 if you want to be exact, of milliseconds of average latency. So per hop, I've got about 8 milliseconds of application latency, not network latency, not one packet to the other, but from an application perspective. So what we want to do is we want to actually, let's have a look at what the performance is like. So what we've got is, you'll see over on this side, there's a performance overview and a performance overview PlexNet. What I've done is I've taken the standard performance overview and modified the dashboard. Now, the only thing I've done with the dashboard is I've actually added in application versus network latency. So I can see the difference between the application and the network. As you can see, there's a legend down here. And I've added in a couple of other bits and pieces. I've added in 0 windows and things like that, because what I wanted to do is I wanted to have a screen that gave me everything in one snapshot. Now, it's very easy with this. You can go in and you click on the little down button and you can go view, edit, share, explore more. You can duplicate that window and then you can just change it. So on the fly, you can actually change your dashboard design and do it the way you want to do it, save it as your own dashboard, way things like that. So if you've got things that you specifically want to look at, you can actually make your own dashboard. You could do DNS versus network latency, or DNS versus that, I mean, whatever you wanted to do. It's really, really easy to do. So what we're going to do is we're going to go and have a look at the client IP. So now we can look at the network latency. So the IOTA is giving us a network latency of round trip time. So you can see that my client takes on average and on max, because it's only a chunk of data, 11.66 milliseconds for a round trip time. You can also see that the gateway does it in 11.6. So what we're looking at, and I don't know, if there was a webinar with Profitap a week or so ago, maybe a couple of weeks ago, where Mike Panucci actually used IOTA, but he went in and did this analysis using Wireshark. Now, I was looking at that and went, well, you can do it without using Wireshark. Now, I could take these packets and I could then go back and say, right, look at my gateway and now look at my IP address and see where the duplicate packet is, and then have a look at the timestamp difference. Yeah, you could do that. It's a lot easier without packets, just to say, right, let's have a look at my gateway, let's have a look at my client, and let's have a look at the difference. Okay, if I zoom that window out, then the average and the max are going to change. So really to understand it, on a per second or per couple of second basis, you really want to zoom in to give you some good understanding, and then maybe pick a couple other spots. But for the sake of doing this, you can see that the average round trip time is 60 microseconds. So 60 microseconds from my network to the other side, which is across 2 devices. So if you sort of assume that maybe the round trip is divided by half, say it's a totally synchronous network, then I'm getting about 30 seconds latency each way. It's going across 2 hops. So I halve that again, assuming that one box is equal to the other. I'm looking at 15 microseconds per device. So I certainly don't have an issue at all with my network. So really easy. I don't have an issue with my network. I don't have an issue with my latency. So, it's very easy to see. And maybe what the problem was just, user perception. And the problem with a lot of these times is that, is it the network? Is it the application? So I've showed you how to look at the application. I've showed you how to look at the network. You can even see the application here as well. I've showed you the network, but a lot of the time it's the user's head. They think it's slow, or they're just, a bad device or something like that. And they just decide to blame other people. So what we can do is we can go back to the application latency. Let's just go back to the user experience and the application latency. And what we can do is I can then say, well, let's zoom out just to have a look. We can zoom, we can go back into our normal custom time zone. Let's just pick 20 minutes. Say, yeah, 1340. Now suddenly, so what I've done is I've kept my protocol. I've kept my http.apple. So it's obviously going to the Apple servers. And as you can see, I'm now looking at everything. But what I want to do is I actually want to get rid of this one. This is a red herring. I mean, as you can see, I've got, that's my gateway address. 171 is my client, and these are other clients. But because this is duplicating traffic, I want to actually say, filter out that value. I don't want to see that with relation to everything else. So as you can see, the client that's experienced something has a max latency of 178 milliseconds. So yeah, there was a slowdown at some point in time because other users are seeing a very good response. Average latency has probably been popped up by the fact that the max latency here is 178. All the other ones are sitting around the average latency and max latency. So they're all pretty good. They're all pretty consistent. So I could say, you know, this is it's not as a dramatic effect as what we have seen out in the network, but this is a really easy way of saying, yeah, okay, it's something that this particular client is going to that is different from all the other clients. So what we want to do is the really easy way is you can do a couple of things, but I'm going to show it just for to show off things that you can find. Let's go to the hosts. So where are we going to? Yeah, we've got the host name. We've got a couple of different devices. We've got server host names here. We've got Apple, Akamai, and TPG. We knew that from previously, there's things going to TPG, there's things going to Akamai, and things going to Apple. So, you know, you could have some network latency with each of those. So what's a really easy way of doing is like, without going into these things, that's just to give you a site view version. We can go back into, server latency. So we can start to have a look at what servers are delivering that and what's their application latency. And as you can see, 17.11.103.100 is the main offender. Now, if you can remember, when you went back, that Apple TV was actually, that's max latency was 178.23, which is that server. Now, if you don't believe me, we can actually go in, we can say, let's have a look. I think it's in performance overview. We can actually have a look at that client IP. Yeah, and that's the server there. So yeah, and that's the server IP there, which is giving me the most data. So very quickly, we've actually confirmed what we found. So we've actually found that, yeah, it was a server problem. It wasn't a network problem. It wasn't an application per se problem. It was just one specific server that was giving that delay. So really, really, really easy way of just going in and having a look at what's going on. So the final bit of example here is go back into a custom time range. Going to go back yesterday, just for some examples. And we're going to look at a bigger window this time. Going to look at 820 to 1410. Okay, not very interesting because I've got a whole lot of filters up here. I'm just going to clear those filters. And I will go back to my dashboard quickly, but I don't want to stay there. So 820 to 14. So as you can see, I got a lot of traffic. So if I'm trying to, you know, look for problems in the network, or say we've been told that there's network problems, the network's running slow. I mean, everyone gets that everyone gets that old chestnut is the network's slow, there's a problem. And so it comes down to network engineers to work out what they're going to do. The problem with zero windows and retransmissions is that zero windows are either associated with client problems or server problems. I mean, they're very easy to find. You can get trace files and go, yep, there's a client problem or there's a server problem. You can go from there. Retransmissions tend to point towards network problems. But it can also be, you know, a server hooked up or things like that. So trying to understand that sort of stuff from a remote site, you actually want to get into that remote site. You don't want to be outside. You want to sort of see what's going on inside that remote site sometimes to give you a bit more information on what's going on. So really, really useful. And especially you don't want to have to send an engineer out to try and find this stuff at times, because most of the time what happens is that the problem goes away as soon as a person turns up. I mean, it's like you know, you get a squeaky noise from your car, take it to a mechanic, and sure enough, as soon as you get it there, no squeaky noise. Mechanic thinks you're, you know, overreacting, and then you go back, and then as soon as enough on the way back, you squeaky wheel again or squeaky noise, and you're sort of stuck in this problem. So you really want to have something that's out in the network and just, you know, capturing data for a long period of time, and then be able to triage and go back and find bits and pieces here and there. So what we're going to do is we're going to go to the performance overview again, because performance overview's got a really cool set of data. What you can do is you can get some really busy sort of data here. As you can see, we're looking at a lot of traffic at the moment. We've got almost a whole day, or, you know, pretty much 8 to 4, so 8 to 2. So we've got a nice sort of 6-hour window. We've got a lot of things going on here, application versus network latency. We can see that, very busy graph. Lots of network latency, lots of application latency. You might look at some of this and go, my God, what's going on in your network? Well, you know, I could sit here and try and troubleshoot this all day and things like that, but, you know, there's other things that I've sort of got to do. But one of the things I sort of wanted to try and zero in on, sorry, no pun intended, was zero windows. So we can see that out of all this stuff, we really only have a few number of zero windows. And we're sort of saying why we've got zero windows. So you can see that I've done zero windows by application. I've got zero windows server, zero windows client. So these conversations are seeing this information here. So what we're going to do is we'll filter down on the max zero windows here. And so we can suddenly, we get a whole different view. Just by filtering out one server window, we can actually start to get a bit of an understanding of what's going on. So what we can do is then we can actually say, well, let's filter on this, this IP. Remember, this is our gateway. This is our, whoops, sorry, downloaded the packet by accident. This is our gateway. This is our server. We know that zero windows come from a client. So if a client initiates a zero window, the gateway is going to see a zero window as well. So we know that there's a zero window, so we don't really need to see the gateway as well. So what we'll do is we'll filter on this IP and source as well. So now we've got a very specific bit of data. And if I went back to, in that time zone, if I went back to looking at that point in time, I'd probably see whatever the data is. We can quickly have a look at the dashboard. We can see there's only 3 meg. So we've done, so there's not a lot going on, but the zero windows, obviously, there's you know, not a lot of stuff happening. So we can sort of go back and say, right, well, let's look at the TCP troubleshooting area, which is another good little debug tool. So TCP troubleshooting is a default dashboard with IOTA. TCP troubleshooting with zero windows is something that I've added. I just wanted to have all my TCP stuff all together. So as you can see, you know, we're only really looking at this bit of information. Server congestion, yeah, we've got some zero windowing events here. You can see round trip time back to the servers. You can see my round trip time per client. I can see my TCP ports in use. I can see my retransmissions. So there's a few retransmissions there as well. Lost packets, of course, I can see a few lost packets. But there's my out of order packets as well. So we can open up these windows, a few out of orders. But generally, there's my zero windows. My zero window is, I've got 13 zero windows just in one spot. So what I could do is I could grab that. It's only 3 meg. So I can then hit download PCAP. So if I click download PCAP, the PCAP comes down. I've actually pre-done this, so it makes it quick to open up. I've actually done this, and I've pulled my PCAP into my capsa. So as I can see, zero windows. This one is the example here. Hopefully the screen's not too small. So I'm actually going to play this back. So I can see out of those conversations, that was my user. We can actually go into having a look at the summary. So there's our packets. We've got a number of TCP events, TCP total protocols. We've got some diagnosis. So my diagnosis, tell me there's some retransmissions. The 0 windows is actually picked up by a filter. This is really just showing retransmissions. So if I go into the packet matrix and I bring up, say, my TCP window size, I can now see that I had 13 0 windows. However, some might see, if you can see this easily, you can see that there's actually 48 0 windows. So the difference being, why is there 48 in the packet capture? Why is there 13? As you can see, 13 0 windows. Well, what I've actually found is that the way IOTA looks at 0 windows, it looks at it as part of an acknowledgement or something that's part of the handshake or part of the request mechanisms through TCP. What it doesn't look at is it doesn't look at resets and resets with 0 windows. Neither does Wireshark. So if I bring this into Wireshark and I do a TCP analysis window 0 window size, I think it is from memory, it won't give me my resets either. It'll give me just my ACK. So this ACK to this ACK is actually, there's actually 13 of them. You know, you can count them if you want, but there's 13 of them. But the rest are all resets. So whilst the reset is technically not causing problems, it's actually not the correct way of terminating a session. It shouldn't be sending a reset with a 0 window back. So something's a bit different. And this is actually an iPhone, this is iOS. That 230 is actually my iPhone. So whatever the way iOS is working, it's sort of doing something that's not quite right. But really, really easy way of picking up window sizing. And then what we can do is, now that we've got those 0 windows, we can start maybe investigating a little bit more. But we're only really starting to investigate in this area where, for argument's sake, you know, you've got packet number 778. And 778, if you want to go to, we can go to the TCP conversation. And we can actually look at the packets. So we can go down here, get rid of my retransmissions. Sorry. So we can then just scroll down here. Right, so in this flow here, this HTTP, we can then resolve into there, and you can see within that side, that's where the 0 window appears in here somewhere, 778. But very easy to drill into it now. In Wireshark, you would actually have a whole lot of data, and then you'd have to follow the flow and things like that. Very easy to go in and then start to triage this way. So get you to the packets really quickly. And so now we've, instead of having 3,000 odd packets, we're now looking at, say, 2,415. So we're getting down smaller and smaller and helping the triage. But it really makes things a lot easier when we're using IOTA to do a lot of the pre-filtering. So what we're going to do is, lastly, we're going to go back to our performance overview, and we're going to get rid of our source. And this time we're just going to have a quick look at, you know, we saw back to this server IP, we saw, you know, retransmissions. So a really easy way we can do it is we can then go in and we can filter for the value. We can actually say, filter out the retransmissions for this one. And so then we can start to understand what's going on with the retransmissions. So, you know, very easy to go from one client, one server, and then filter on a retransmission scenario. So in this case, it's actually a different IP. Before it was my iPhone, which was giving me 0 windows. So I wasn't actually getting, in that particular conversation, I actually wasn't getting 0 windows, but now I'm getting client retransmissions. So very easily, you can then go and have a look at that. We can go into, say, TCP troubleshooting with 0 windows, or troubleshooting with retransmissions. So then we can see, interesting enough, we get a retransmission at around 12 o'clock. Now, what I found is this IP is actually my wife's iPhone. Interesting that you get a retransmission or packet loss, because it was packet loss as well, that you can get packet loss at the same time. So, you know, it might have been a wireless event. You know, she might have roamed from the front to the back, things like that, gone out of wireless range. So something could have happened there. But trying to drill in sometimes and find this information is really easy. So then I can just actually, again, I could download that packet, go back into my packet capture here, which I've already done, and I can then say, right, there's my retransmissions. Okay. I play that. And I've only got 129 packets. I can go in there, change to my TCP analysis retransmission, and there I can instantly see I've got 3 retransmissions. I can see that it's coming from the local source, and then one's coming from Apple. So really, you know, there's obviously a network problem somewhere out there. It wasn't on my side. We weren't seeing lost packets. The lost packets weren't being there. So it's obviously coming from the other side. Something has sent one back, it's been lost, so it's tried again. We've tried to send something out, it's been lost, so we've tried again, and it's come back. So out of our control, but you know, if we had lost packets on that as well, that was related to the internal IP addresses, then we can start looking at. So we can see that it's actually out of our network, not our fault. So if you're in a remote site, then you'd start to look at, well, it's not the remote site, it's nothing in there. We've now got to look at what's in the hops between the remote site and say the other site or the destination or the server farm or wherever the case may be. So at least it starts to give you maybe a little bit more visibility into where you can start to see where things are going. We're pretty much done. The only thing I wanted to say is, you know, DNS is always an issue. And sometimes you sort of find some weird things happening in DNS, and DNS can cause application problems as well. You know, if a DNS server is not responding, you go to www.plexnet.com.au and your DNS is problematic, then, you know, our website could be slow. I mean, at times our website is slow because, you know, we're going through a couple of things there. But, you know, DNS can really cause some dramas. So sometimes just understanding what's going on with DNS is quite interesting. So the other day I was looking, just when I was preparing for a few things here, I actually was looking at a window time frame around a couple of hour time frame. So I'll get rid of clear all my filters. And all I'm going to do is I'm going to bump straight into DNS. So this was the thing that interests me. I was doing like 249 megabytes of DNS traffic. And I thought, what the hell is going on with this? So I then do an overview and I can see all my requests. I can see all my DNS responses. I can see DNS surveys. There's also, because I actually run my own DNS server, I run a efficient IP DDI solution inside my home office / lab. It's doing a lot of root lookups, but you know, you can very quickly go in and have a look at most query. You can then zoom in again saying, what was 150 meg? Right, that's my DNS servers. Oh, we didn't maybe get as much data. Maybe I should zoom out a bit more. That's a bit better. So we can actually see, I actually didn't pick the whole time window. So there we can see what's going on in terms of the DNS server, who's the top DNS server, all the other requirements, all the other requests, and the reply codes and things like that. So you can drill in a lot more just to look for any DNS issues. So that's pretty much it. I mean, didn't want to spend too much time doing that. So I guess we just go into if there's sort of any questions. And also on the panel, I should have actually mentioned, on the panel we've got Sergio and Artie. Sergio is my business partner from PlexNet. Artie's from Profitap. So I don't know if there's any questions, guys.
Wasn't there just a slide to explain the benefits, Dom, or just why it's so important?
Yep. Okay. So basically going back to here, so what does cost effective mean? You know, cost effective can mean a number of different things. Cost effective can mean cost effective mean time to resolution. I mean, if you have to go out and get a Wireshark guru to go through megabytes or gigabytes worth of packet capture, that can take a long time. So something like, a small capture device that can actually give you back in time features and help you get to mean time to resolution quickly. Now, my examples were fairly straightforward. They weren't overly troublesome. The problem is that if I was trying to find the effect of YouTube traffic on my network through Wireshark, I mean, it would be a hell of a time, because it's all UDP. I'm trying to I can't do TCP follow the flow. It makes things easy. So being able to go back in time and able to find that mean time to resolution quickly. I mean, I found this in about 5 minutes, and then I went out, I found out what it is. I went out to my son and said, hey, were you watching? He goes, yeah, I did it for about this time. Bang, there you go, there's your question. Not even have to download and search through large PCAPs. I mean, that makes things incredibly easy. I mean, you don't want to get to the PCAP if you don't have to. I mean, if you can get to 99% of your problem resolution without going to a PCAP, hey, you're a winner, because going to PCAPs mean you then have to start getting into the weeds. Now, sometimes you have to. I mean, if you're trying to look for retransmissions, if you're trying to look at the direction of retransmissions, if you're trying to look at what device is doing the zero windows and where are the zero windows appearing, are they all appearing at the same time? Are they spread around the place? If they're all at the same time, then you certainly know that it's a device problem or a server problem. If they're sporadic, it's a bit harder to sort of ping that down, and that just happens. But also getting to a usable problem quickly. Secondly, cost of remote deployment versus cost of dispatch engineer. I mean, if you've got to go out to, especially in these university campuses, especially in schools, like, we deal with Department of Education and a number of different unis. I mean, there is schools and unis all over the place, and not all of them are in the capital city. So, I know there's universities in Victoria and University of New South Wales and Queensland that have different campuses all around the place. So how do you get to a campus quickly? Well, what you can do is it's cost of a remote deployment versus the cost of the engineer. Do you ship an engineer out there with a laptop, hoping that at that point in time they're going to capture the data? Or would it be easy just to ship a small device out into the field? You just put in the post or put in a courier, send it out. There's a button on the side which you can start capturing. So realistically, the only intimate knowledge that a person out on site needs to do is to get a span port or a tap port out of the network, plug it in, and then hit a button. And then you can then centrally manage that across multiple units, even if you want to. So someone sitting at a centralized site can go out and pull up 3 or 4 different sites that may be having issues and look at them all really easily and getting to that problem quicker. And of course, hardware, software that won't cost the earth. I think gone are the days where, we were selling $150,000 analyzers here, there, and everywhere. I mean, they have their place. They've got deep packet inspection. They've got huge storage. They've got high speed. So they have their place. But I mean, in sort of a university or an education area, or even an enterprise that has a lot of remote sites, deploying big boxes like that is not scalable, and it's very hard. So you want to look for hardware, software solutions that are cheap or that are inexpensive. I mean, Wireshark is the cheapest of cheapest. It's free, but it doesn't always save you time. So there is a difference between cheap and then paying some money for something that's going to save you a lot of time, a lot of headache. So that's effectively we're done. So we pretty much got 5 minutes for questions, and then we can call it quits.
Dom, there is another question. I think you've already answered it just now, but one of the attendees is asking about your experience with network performance monitoring tools and why you wouldn't deploy a probe, for example, to replace this. I think you already touched on it, but if you don't mind.
So why would you deploy what?
A probe.
Oh, so I think the main thing is we've dealt with probe-based solutions, and we still deal with probe-based solutions. I mean, don't get me wrong, probe-based solutions will give you a lot of visibility. It's just that with probe-based solutions, you usually have a central management system. You usually have a large database store, and it's not easily deployable, especially if you start looking at multiple campuses or multiple schools or multiple sites. I mean, schools, what is that? 2,000. I can't even remember the number of schools. I think, Sergio, you might know the number of schools we've got in New South Wales, but it's in the thousands. So it's just not cost effective to put a probe in every single school. Even in some universities, you're trying to work out a problem in a campus. You can't put a probe in every single campus office, you know, on the off chance that there's a problem. I mean, centralized monitoring tools will look at application deployment going out, but sometimes when a centralized tool will show a problem at a remote site, that's when you might have got to triage that remote site. So it's a little bit more ad hoc. And I think that's the difference there, Artie, I think, or whoever the question was. It's you know, you need to look at more ad hoc troubleshooting and not being as expensive as what the probe systems can come up to.
Great. There's another
yes, Dom,
question, Dom.
Sorry. Yes.
That's
just butting in here. There were about 2,100 schools. When the guys looked at the budgets of putting out stuff in 2,100 schools, you can imagine that was astronomical. So, and it's not to say they will or won't go for IOTA, but it's a consideration because, as you say, when the schools thing starts having problems, they can just quickly ship it out, get somebody just to plug it in and press the button. You don't need expertise on site. And then from a central position, they can get in and start troubleshooting. Yeah. So it's not that you don't need central management deployed probe solutions. It's that sometimes this becomes more cost effective from a troubleshooting perspective.
And we've had the same experience with some of the universities as well, and as well as enterprise customers. I mean, I guess we've concentrated on the school university type of mantra, but I mean, anybody with a remote site, I'm in a house, you know, work from home scenarios. I mean, it's a little bit overkill sending out that sort of stuff to work from home, but you know, if it's the CEO trying to work from home, maybe that's, you know, you've got to do it. So to try and find it, but yeah, certainly that's easy.
There's another question about the storage capability of IOTA. I can answer the question. The question is specifically around 1 terabyte these days might not be sufficient, and what other options do they have? And the answer to that is in our next release of IOTA, we're actually introducing the capability of an external storage. So in theory, you're not going to be limited to any size, obviously, only that of the hardware that you're using.
Yeah, the other thing too that you can do, knowing that, you can actually go into the capture machine, right? And you're just having a look there, right? I've got, you know, enough disk space. But what you can do is you can actually have files older than a certain amount of time that can be deleted. You can also do on the 10 gig unit, you can also do packet slicing. So as you've seen there, we've sort of said you can find a lot of problems just by metadata without going to the packets. So what you can do is you can typically packet slice out, and you can actually see what's going on there as well. You won't get, of course, you won't get the payload, but you will certainly get all the things in terms of network latency, application performance, things like that. So yeah, you can do that, but as you said, Artie, it's actually, or I think it's coming out like literally within a month or so, within this month or something, or this quarter. Yeah, the ability to do remote storage, which is taking off the scenario from the Profitap. The Profitap was basically an IOTA without the hard drive that only wrote to a PC or to a storage device. Now IOTA will do both. So you'll be able to have the opportunity to do either 1 terabyte internal or an external NAS externally. Okay. So if we don't have any more questions, we can, how about that? What is it?
No, there's no further questions.
2 minutes too. I think we've tried this before. Okay. Hopefully everybody's enjoyed what they've seen, and yeah, we'll catch you later. Okay, cheers.
Thanks very much, Dom.
Thanks very much, everyone, for attending.